to let Richie and David Brown kind of talk about themselves, talk about the work they've been doing, and really just let everyone know what one of SOAR's projects have been and how we're helping out the community. If you need continuing education credits, go ahead and shoot me an email at the end of this webinar, and I will get a certificate to you. Other than that, if you have any questions, please let me know. I'm keeping everyone on mute and turning your videos off just so it's not distracting for the rest of the group. But on top of that, we will take questions at the very end. So if that's it for me, I am going to hand it off to Richie.
All right, thank you very much, Tony. Good morning, everyone. Do I have the ability to screen share, Tony, I guess? Let me go ahead and... looks like I need to, okay, there we go. Okay, let me get this presentation slide going here. Okay, good morning, everyone. My name is Richard Tarver, and I am the Data and Collections Manager of the Oklahoma Geological Survey, and I'm also the Facilities Manager of the Oklahoma Petroleum Information Center, the OPIC facility, which is the core and cuttings and data repository for the Oklahoma Geological Survey. Let's see, I'm gonna edit this. Okay. So today we're gonna take a look at the Oklahoma Geological Survey's OPIC facility, give you a little background on that, as well as an overview of one of our current SOAR-sponsored projects, which is our interactive well viewer application. And let me get my slide working here. Okay. So our well viewer application will provide access to a lot of our well data, publications, and other state natural resource data that is currently available to the public. So for those of you who may not be familiar with the Oklahoma Geological Survey as a whole, we are a state agency for research and public service, and we're located at the Norman campus of the University of Oklahoma and affiliated with the OU Mewburn College of Earth and Energy. Now, the survey is chartered in the Oklahoma State Constitution and is charged with the investigation of the state's land, water, mineral, and energy resources, and disseminating the results of those investigations to promote the wise use of Oklahoma's natural resources. Now, interesting side note, the Oklahoma Geological Survey is actually one of the few state geological surveys that actually have a state constitutional mandate to exist. And here's just some of that statute language. It's in the state constitution. I don't expect you to read that. Just know that someone long ago waved a wand and said, "Thou shalt have a survey," and here we are, and here's the legal proof. So going back into the history, so the survey was established as a state agency in 1908. So we've had over 100 years to amass a wealth of a staggering amount of geoscience data within our history. Here's actually a little current snapshot of some of our current staff. Actually, that's not true. This is Charles Gould, the gentleman here in the white shirt with the dark tie. Some of you may recognize that name. He was the first director of the Oklahoma Geological Survey and the founder of the School of Geology at OU. And here's just a snapshot of some of the activities that the OGS is more broadly engaged in. For those, again, who may not know what we do for a living. Oil and gas is going to be the subject of today's discussion, but there are a lot of other activities that we are engaged in, such as the State Map Project, hazards, water, industrial minerals, and so on. But we're going to focus today on the OPIC facility itself, which a vast amount of all of that staggering amount of materials that we've amassed in our history are stored out at this facility, which is a 192,000 square foot mega warehouse facility and conference center, which contains our core and cuttings facility, data library, and the OGS publication sales office. I like to refer to that as the three pillars of OPIC. And here's a little more of a detail on those departments. So the facility was initially seeded by a donation of several 100,000 boxes of core and cuttings materials from the BP Amoco facility in Tulsa. And this initial donation sort of served as the coral reef of subsequent donations that would follow. Presently, the OPIC facility has over 500,000 boxes of core and cuttings materials associated with approximately 30,000 wells throughout the state. Now, we also have core and cuttings materials and other data from about 47 other states. So while our focus is always going to be primarily on Oklahoma, we are starting to envision the OPIC facility as a burgeoning mid-continent core and data repository. And here is a snapshot of our facility and some of our staff. Now, in addition to the vast core and cuttings warehouse spaces, we also have a core viewing room where we facilitate layouts for our patrons, as well as putting on core workshops for the public. Some of you may have attended those in the past. This one here is a shot from one of the more recent ones back in November of last year. And there is, I believe we're working on virtualizing these workshops going forward for the foreseeable future. And we will have more information on that on our website. But also within our repository, we have a well data library, which houses a lot of this material that we're going to be looking at here in the well viewer demo shortly. So we have vast collections of electric logs, mud logs, scout tickets. We even have a nice big aerial photo collection. So it's just a staggering amount of material. And here's a little glimpse at some of our materials in the data library. The main event, so to speak, out of our data library is the log warehouse. Now, the OPIC facility is the official state repository for hard copy full-scale logs, of which we have approximately 800,000, give or take. And in addition to logs, we also have a collection of other strip logs out there and things that are more historical in nature. A lot of the materials have an archival historical bent, meaning that a lot of these materials are not going to be duplicated in a lot of other collections throughout other state repositories. So finally, the third pillar of OPIC facility is the publication sales office. So in addition to merely accumulating data over the past 100 years, we've actually been generating data in terms of geological scholarship during this time. And we've outputted that to the public in the form of field guides, geologic maps, hydrologic atlases, and much more. So this is also where, if you want to come and visit us in public and purchase these materials, you may do so, or at least before March, that was the case. To be decided on when we will resume full public operations to the public. But all that to say is that we've managed to accumulate quite a bit of data at the OPIC facility. So what are we doing with this? So historically, the Oklahoma Geological Survey has been a very analog society. Over the past 3 or 4 years, Associate Director David Brown and myself have embarked on the task of virtualizing these holdings and making them useful and available to the public. And our goal has always been to try to do that for free with open access. So after consulting with other geological surveys in the region, particularly the Kansas Geological Survey, who are strides ahead of us in their digital offerings, and then also meeting with various state agencies who also possess large silos of state resource data, we compiled this master well records database of all the wells in the state that we have records for. And we began to aggregate the OPEC data that we have, these associated files, all these well data that are going to hang on the individual API record within this master database to provide, kind of a broader narrative of the story of that well. And we're talking here about electric logs, mud logs, core analysis reports, core photos, et cetera. All of these are going to be tied to that key ID of the well, and we'll be able to download those materials remotely, as we'll see here shortly once we get a look at the actual well viewer. So a little history, and I should say that we also had a proof of concept, and we were meeting with our data share partners at the Oklahoma Corporation Commission, the Oklahoma Tax Commission, to synthesize all these state data holdings and make these materials available through the system. And that's something ongoing that we're improving upon behind the scenes. So once we had a proof of concept, and this is a real rough sketch of kind of what we were envisioning back before we partnered up with SOAR, the idea was that we had this comprehensive database of Oklahoma's geoscience and natural resource data, and we wanted to make it available through a spatially driven map-based web application. And so once we had this proof of concept, we partnered up with SOAR the Secretary of Energy and the Environment, and also our own Newbern College of Earth and Energy to begin work on that. So here's a little snapshot of kind of our history here. So in 2019, some of you may be familiar with this beta, and again, we'll be looking at that shortly, but we released a pilot beta of the WellViewer application. And as a result of the success of the pilot, we've now moved on to phase 2 of the project that will move us closer to kind of refining this initial offering and also laying the groundwork for expanding the application towards a comprehensive virtual OGS online application that's going to serve up all of our data as well as other relevant state data all through this system. And again, we're trying to do this all for free because in our ethos, this is state-owned data and citizens should have access to it. So here's a couple slides of the actual data, but we'll go into that in more detail with an actual video demonstration. But just to show, this is kind of where we emerged out of that initial proof of concept. Now in phase 2 of the project, we're going to be focusing on developing enhanced functionality of that initial offering, and as well as optimizing the system architecture, including and expanding upon additional data sets. And in phase 2, some of those that we hope to have rendered are going to be things like the horizontal well stick display, interval maps, expanding on again a lot of these well file data sets such as the logs, scout tickets, analysis reports, etc., and also layering various play maps into the system. So also with the survey, we have a kind of a GIS cartography shop, so we're constantly producing these geo-rectified map products from our publications and converting them into a digestible format through our system. So we're going to be offering up some of those play maps here in phase 2. So, you know, in addition to these deliverables, we're also going to be looking at additional quality control edits, infrastructure optimization, just broadly speaking, multi-device platform usage, and we've behind the scenes I think we're looking at standing up new virtual machines, GIS stacks, increased storage capacity, and backup optimization. It's a big technological mouthful there, but all those enhancements are going to require significant technological expertise, which is why I'm actually very happy to introduce Mr. Mike Kennedy from the OUIT's Digital Innovation Group. This is a group that we've partnered with to execute and accomplish a lot of these objectives of phase 2. So I'd like to introduce Mike and let me defer to him here for a brief update on the project from the development perspective, and then we'll take a look here shortly at a demonstration followed by a question and answer discussion. So if we can unmute Mike and let him kind of chime in here, and then we'll get back to me.
Thank you, Richard. I hope everyone can hear me all right. As he said, I'm the lead of project management for the Digital Innovations Group within OUIT. So who is DIG? We are designers and developers, integrators, technology managers. We're customer focused and outcome driven to ensure the successful use of IT for whatever our customer needs are. And we're really excited to partner with OGS to bring this WellViewer and the OGS Online project to the next level. So there's a couple different ways that, couple different services that we're bringing to this project. One big part of it is the infrastructure and support. We have a large data center in Norman for hosting the OGS Online website. It's a highly secure facility, so physical access is highly restricted. It's even rated for regulated data compliance storage for any sort of governmental or industry regulations on data like PCI or HIPAA. Physically, the facility is tornado resistant. It's quite literally a cement building within a cement building. We get a few of those here in Oklahoma, so have to be prepared for that. The entire operation is designed for a very high level of business continuity so that we can maintain service levels. A few of the ways that we maintain that business continuity, there's an extreme level of redundancy in power and network connectivity within the data center. They have multiple fiber connections to the outside world. They have dozens and dozens of large capacity batteries, as well as 2 giant diesel generators. So power outages, network fiber cuts on the outside, they just don't bring that stuff down. Internally within the data center, there are also multiple redundant network paths. And this is all to really maintain that uptime. This is a big term in hosting world. Uptime is really what you need to go for. We also use the VMware Enterprise virtual server environment, providing high availability. Essentially, any of our hosts go down within minutes, it can switch over to another available host, all without any staff interaction. So that gives you that sort of high level of fault tolerance, another industry jargon term. We also use multiple monitoring systems, both physical and technical. So water, smoke, fire, all those kinds of sensors, as well as within the systems for security, intrusion detection, all that fun stuff. And we support all of that and provide reports and incident management as well. There's also a very large amount of storage available for the increasing number of digital assets that OGS has been collecting. We're talking in the petabytes level, so plenty of room there. Now, all this technology is good, but you really need the right people to run it, maintain it, and manage it. So we're really proud of our systems and integrations team. We have decades of combined experience within that team, managing Unix, Windows, networking, and firewalls. We also do a lot of integration between our systems team and our development team. I don't know if you've heard another industry term called DevOps. Generally, it relates to the integration of systems and development for rapid response and continual development. So speaking of development, that's sort of the second component of services that we're bringing to this project. We have a group that focuses with open source software. That's a really big deal because it keeps our development and maintenance costs way down. So not just the cost of developing a website, but maintaining it over time, called the total cost of ownership. We're really able to keep those costs down. We use a development methodology called Agile. If you haven't heard the term, Agile software development refers to methodology centered around the idea of iterative development, where the requirements and the solution to meet those requirements can evolve together over time through collaboration and constant engagement between all the stakeholders. So the iteration, basically developing small pieces and coming back to it over and over. Well, that allows a lot of flexibility in the development. Anytime, requirements might change on the ground, particularly for a long-term development project, and also allows us to respond rapidly to any of those changes. It also allows the clients and stakeholders to see progress a lot sooner. So that helps as well with that client relationship. The collaboration and constant engagement with customers and stakeholders is also a big part of that, keeping them involved and making sure that our development team is really hooked into the business needs and understanding what it is, what outcome they're really looking to achieve. And it also includes basically a philosophy of continuous improvement. So we use, there's an expression we use a lot, we don't let perfect be the enemy of good. So the idea of constantly coming back to the product and enhancing it and improving it over time is baked into the development methodology and the service that we're providing. So the results, we can produce highly accessible websites using responsive design. Another jargon term, responsive basically means the website automatically adjusts to any device. So it'll look good on a phone, it'll look good on a tablet, just as it looks good on a desktop browser. Our development team's also well-versed in what are called RESTful APIs, basically a way of getting data from other systems and presenting it wherever you need to. And that provides additional data analytics or integration with other platforms, such as pulling from other data sources like OCC and NRIS. So we have a lot of experience in enhancing those data flows. OU is expanded to the ARC Online cloud-based GIS platform. So we're really excited to start integrating with that and working with the GIS specialists to ensure that their maps are displayed with a high degree of quality and interactivity. That's essentially the two main services that we're bringing to this project, and we're really excited to move this along. Thank you, Richie.
That's great, Mike. Thank you very much. And then just, I don't want to put you on the spot, Mike, but like, would you mind maybe real briefly just kind of speaking to the specific team that's actually working, we've been visiting with Todd and, you know, the others, and kind of what their process looks like on this phase 2?
Sure. Well, you know, I act as the project manager, and I have on our PM team a business analyst named Todd Tucker. He helps with a lot of the client requirement breakdown, documentation, review, and presentation. So he's a big part of that client engagement and translating what OGS needs for and actually being able to produce that in development. Cole Harrison is our lead of development. He's got about over 20 years development experience, particularly in agile methodology. And it's his team that's going to be providing a lot of the development support, not only for the website, but the data integrations and analysis. Yeah, I guess those would be the main players from our team, if that's what you're referring to.
Okay, great. Really appreciate that. Thanks, Mike. And basically, so just going back to kind of our timeline. So now we're in phase 2, which began, you know, towards the spring, and we're engaged right now in executing a lot of the optimization that we discussed, and we are feeding and growing our digital infrastructure to demonstrate a lot of the deliverables in terms of being able to download additional data sets associated with each of these well APIs, and we're going to be executing all of this throughout the span of the 1-year project. So phase 2 is a 1-year project. Going back to phase 1, just the timeline again here. So phase 1 was basically kind of a 6-month proof of concept, this pilot. And now we're currently in progress in phase 2, and a lot of the deliverables and the enhanced functionality that we're working on behind the scenes, we're going to start seeing, you know, updates to that throughout the year. But we're, you know, hoping to deliver all the objectives proposed in phase 2 by the end of the year, you know, and maybe into the spring of 2021. So we'll be seeing updates to the system as they are brought, you know, behind the scenes into and integrated into real time. So after we see our well demo here, check back regularly to see, you know, some of our progress, and we've made all of this material, you know, all these update materials and the URLs that are pertinent to the project available through SOAR. So any of the attendees here today are going to be able to have access to that. And I should say that the well viewer that we're about to see is actually, it is live now in its current state. And it's something that we're, you know, constantly working on behind the scenes. But it is available to be knocked around online. So please, if you haven't already seen the product for yourself, we encourage you to, you know, test out you know, the scope of what we have in there right now, and again, we're going to be bringing a lot more into that over the course of the next year during the project phase. So just to recap, so this effort, our mission here is to you know, provide positive impacts to the state, and really It's one thing to have amassed all of this material and let it languish in confinement in warehouse spaces, but it's not really it's not really useful to the public in that form. So we've really put ourselves to the task of getting our arms around these materials, virtualizing them, growing our digital infrastructure, and working with Mike's team to make this a useful product. So that's kind of all of our, our history here, and we really appreciate, again, SOAR and all of our other sponsors for getting us off the ground, and we're really excited about looking into phase 2 and seeing this initial product offering grow. So well, thank you there. But I'm going to go back here and switch up my screen to show you a little video that we've prepared as far as a demonstration of some of the basic functionality of this initial offering. And a lot of the deliverables we're going to see are going to be kind of iterative. So we're not going to be seeing all of the deliverables proposed yet in phase 2, as we're currently engaged in that project again throughout the course of the year. But without further ado, let me go ahead and switch gears here. Sorry, Tony, can you give me back the screen share there? Okay, thank you. Okay, and here's a little demonstration video that we put together, and we're going to have a little question and answer session after that.
Today we're going to take a look at the Oklahoma Geological Survey's Well Viewer application, which is an interactive spatial mapping tool that allows us to look at different data sets pertaining to geoscience materials and natural resources throughout the state. So first we'll take a look at some of the basic functions. And here we have the home screen, the layerings, and the legend to begin with. Real quickly, we can take a look at some of the different map layers, which can be toggled on and off depending on what we want to view. Another option is just to zoom in here. We have our section, township, and range grid on, and we'll go down to the map labeling, which will actually show different wells as they are distributed throughout the state. Now here again, we're using the Oklahoma Corporation Commission data set, and we also have our in-house Nris data set. That's the Natural Resources Information System. Combined, these two data sets generate the composite of our master well records database. And again, here is the legend, which will denote the different types of wells that we're looking at. Another feature of the Well Viewer application is the base map utility, which allows us to toggle on and off different base map views depending on which we would prefer to look at. For the purposes of this demonstration, we're going to default to the topographic layer. For downloading well logs, we have a basic search criteria that enables to search for different logs. Right now I'm going to use the API number for an existing well number that I'm certain we have a log for in the system. But one of the first things we're going to want to do prior to viewing logs is down here in the sidebar, we want to download the Preview Log Viewer app, which is essentially a TIFF viewer, which will allow us to view the logs once they're downloaded. And here we have a listing of the available log types for this given well, and we're going to select a couple electric logs for demonstration. And again, we'll be able to download these to your computer and save them to be able to view going forward. And you'll notice here that the system generates a compressed folder with the logs that we've selected. And once they are downloaded, we will be able to view within the previewer application. Right now, we're going to take a look at one log in the viewer, and we'll show the single view. Here is the electric log that we've selected. Now, the TIFF viewer app itself has a lot of useful tools that we'll explore a little bit of those here as we do a side-by-side view of two logs that we've downloaded. Now again, this is the Weatherford TIFF viewer application, so some of you may be familiar with that. So we take the second log here and add it to the existing log that we've viewed, and now we have a side-by-side view of both logs. The side-by-side view enables a couple of useful analytics that are built into the TIFF viewer app, such as the ability to generate a cross-section or any other spatially oriented metrics. For example, we'll throw in a horizontal line just to show a demonstration of some of the tools that come along with that TIFF viewer app. Next, we'll look at downloading some core photos. Similar to the electric logs, we'll go ahead and enter into an API number that we already know of an existing well, of which we have core photos. And we'll go ahead and zoom on the well here. And on the sidebar, this will bring up the core photos that we have accessible in our system. So we have some butt images and some slab images here, and they're arranged according to depth intervals. And we'll just randomly select a couple to view. Now you can view as many as you want. These are going to be available to preview as well as download. Now most of our core photography has been scanned at a resolution of 600 dpi, so this will enable a pretty tight zoom on some of the features of the core, which going forward this will be a helpful tool for remote viewers who will then be able to schedule layouts within the system as well upon viewing the core photos. And again, we can cycle through the previews that we've selected up here just by choosing the different arrows. And we can go through the different depth intervals that we have available for that core. Here's another slab box, for example. And again, these are available to preview as well as download. Now let's take a look at viewing and downloading some core analysis video. Again, we'll enter our API, and we'll go ahead and zoom on that well. And we'll pull up a selected core analysis video for demonstration purposes. And again, we have the depth intervals listed. And we'll select one video here. And just like the well logs, the system will automatically generate a compressed folder, and we'll just open that folder up to select the file, which we can now view. We'll have a variety of different core analysis videos to choose from. This is just going to be one of the types of core analysis that we'll have available for demonstration purposes. So that gives us an idea of some of the basic file types that we can view through our API search for specific wells. But let's take a look at some of the map layers that we have available through the system to utilize some of the more broad dataset driven layers. So for example, we'll open up our layers here and take a look at some of the mud logs we have. And each one of these dots represents a well for which we have a mud log that has been scanned and inputted through the system, which is available for download. And here are some of the electric logs that we have, about 100,000 in the system right now, as well as some core photos. And this layer represents some of the physical core that we actually have at our repository. So those would be available, ideally to look at in person. Now, as we get into the digitization of our publications, we have quite a few that we've amassed over our previous 100 years of geological scholarship. And we're anticipating these to be viewable as a discrete map layer, which here we can zoom in concert with another layer, which is the section, township, and range grid. And there's a helpful utility, which is the ability to adjust opacity for when we're looking at multiple layers. Now, all of these layers are basically the offerings of our initial pilot beta of the well viewer application. So in terms of mapping and other digitization projects for our publications, for example, we have a couple play maps that we're planning on incorporating into the system in the not too distant future, as well as expanded search criteria and just expanding upon our existing data sets. And finally, here we're zooming in on a surface geological map, just to illustrate another mapping layer that we hope to expand upon. So again, everything we've seen here today is the culmination of basically a 6-month project where we were tasked to generate a pilot beta for this application. And going forward, we're planning a lot of expansions upon the existing platform into what we're calling a phase 2, for which we have been successful in receiving some funding towards. And on that note, we would like to thank our sponsors, without whom this would not be possible. And we will be communicating updates about this project through our website at ou.edu/OGS. And in the meantime, you are able to access the OGS Well Viewer pilot at the following URL. Thank you very much.
Okay. So I'm going to go ahead and bring up the live site while we go ahead and take a pivot towards any questions that the audience may have. And just real quick before we start the questions, I just wanted to acknowledge again our associate director, David Brown, who is out there in the audience. David, is there anything you want to add before we get into the questions?
Well, first of all, good morning, everyone. I am David Brown. I'm the Associate Director of the Oklahoma Geological Survey. And I thank you all for attending this presentation. Richie, thank you very much for your overview of the system and the project. And Mike Kennedy, I thank you and your team as well. I'd just like to say that I came about 5 years ago to the survey, and one of my ideas initially was to take that 100 years of existence that the survey had and scholarship and bring it into the modern age and get all of those maps and data and resources and make them available to everyone in a digital format, and to do so for free. Because as Richie said earlier, this is really the state's, it's the people's data. So they should have access to these things. And that's what we're doing. We reached out to others who have done similar things, particularly our friends in Kansas at the Kansas Geological Survey. And I want to publicly thank them for their cooperation and help. They've been nothing but helpful to us as they showed us the things they've done over the years. I think they've done a fantastic job. And we intend to be successful in this going forward. And we even have a little of kind of a tongue-in-cheek, friendly competition with our friends in Kansas. We told them we're going to catch up with them and we're going to pass them. So, and that's okay too. But Mike Kennedy and the IT team has been a tremendous asset to us. We appreciate your team very much, Mike. And I hope that everyone on this call was impressed with the sense that this isn't just a couple of guys. It's not Richie and I just sitting with a Commodore 64 trying to figure out how to make this thing work. Mike Kennedy and the IT team brings a tremendous amount of development support and support in general after the fact to help us do this the right way. So it's a huge project, but none of it would be possible at all without the help of our friends at SOAR and OERB. So I can't thank you enough for that support. I look across my Zoom screen here. I know we're all in a new world these days with working from home, or some of us are back at our offices, but I'm glad we have this technology. As I look at what I call the Brady Bunch view, as I see all of your names and pictures across my screen here, I see a lot of friends out there that have joined us today, and I hope you're seeing some benefit in this. I think it's going to be very beneficial. And while this is focused primarily, on oil and gas, well data and logs and core and so forth, that is true. That's what we're going to continue to produce here. But this is going to push us to a whole new level. You've heard us mention the OGS app. Imagine an OGS app that one can download, and then access the oil and gas data, for example, or perhaps it's water data that you're after. Richie Tarver himself personally is an archaeologist, and he has a project he's working on. Imagine being able to access that in part of the app. So, and they'll all work in a similar way. So if you get expertise in using this, you could easily translate that to using other parts of all the data we have at the survey to make available to everyone. So thank you so much for supporting us, and we do appreciate your input. I saw some questions already pop up, and we look forward to answering those here at the end of the session. So with that, I'll turn it back over to Richie. And again, thank you very much. And Richie, if I've missed anything, here's your chance to say so.
No, that's great. That's a great summation. Thanks a lot. And again, we're trying to realize advances in technology to sort of bridge the gap from where we have been as this kind of analog society versus where we hope to be in the 20th century, much less the 21st. But we're going to utilize technology and experts out there like Mike Kennedy and his team at the OU Digital Innovations Group to really help us bridge that gap. So that's basically what we intend to do going forward. And so we'll go ahead and get into the questions now. But let me go ahead and make that available. So yeah, a lot of questions about Osage data, and that's something we've certainly been cognizant of. If you look at our Well Viewer app, and I'll just go ahead and throw up the live website here. If we look at, for example, I'll load up our electric log map layer here because it'll reveal a certain data shadow at a certain part of the state. But we have made some inroads there. David and I have attended a lot of the Osage Tribal Council meetings, and we have had discussions with some of their officials there, and there seems to be a pretty warm reception to data reciprocity. We've been offered some materials, and we didn't get a chance to capitalize on that before we were shut down during this pandemic. But we definitely have designs on opening up that dialogue, and they had a lot of materials that they were ready to go ahead and donate to OPEC, and we're talking about any tools that we can provide through our system that helps their operations out, as well as making that available to the public. And then another question I saw that was great, and this is kind of our grand vision when we get into our data share partners, such as the Oklahoma Corporation Commission and the Oklahoma Tax Commission. We're really going to be trying to get into updates for our database, which is right now primarily driven by two data sets that kind of make up our composite of the master well records. So we have this, our Oklahoma Corporation Commission, our basic layer for wells, and then we also have our in-house, this natural resource information system. And you can see once we toggle both of those on, there's a lot of overlay there. So we're going to be rectifying a lot of those, kind of systemic issues. But combined with the updates we're going to be getting, and we're hoping to get those updates, every 24 hours going forward. The idea is to utilize some cron software and plug into their system. So we're going to be harvesting updates from our state partners and serving them up through this system. The idea was to have a comprehensive single online source for not just OGS data, but for also all the publicly available state data that's relevant to the system. We have partnered up. We've had several meetings, several collaborative efforts throughout the years with the Oklahoma Corporation Commission and the Tax Commission. In fact, the electric logs in the system right now, these are part of the image archive that we received from the Corporation Commission, and we were given access to that. Now that reciprocity arrangement will lend itself towards things like 1002A completion reports and other holdings they may have. And again, we're emulating that Kansas model where the Kansas Geological Survey has really stepped up to the forefront to be the one single online source for accessing all of this data through this, kind of aggregate filter. So that's the plan going forward is, yes, we want to be receiving all updates in real time, especially from the Corporation Commission. Now, I know everyone is excited about the production data, and that's certainly in our crosshairs. We do envision that as a subsequent phase in and of itself. There are a lot of issues with Oklahoma production data, as many of you know, and making it accessible through a database form is going to take a little bit of work, but that's something that we've always had our eye on. And again, we envision that as a subsequent phase. I can't promise that it'll be phase 3, but it will certainly be, within the next, 3 or 4, it could be phase 4, but, but we have been granted access to the Oklahoma Tax Commission system. So that's something that we are hopefully that we're hopefully going to see within our system as soon as we can get it in there, essentially.
Richie, can I interrupt for a sec?
Yeah,
please. I just want to say that back to the question about Osage data. Richie's right. We have had conversations with the Osage, and particularly the Osage Minerals Council. They like this delivery system that we're building here. I will say, Richie, I think we have some Osage data in the Nris data set itself. So if you were to look there, you can see that we have, for Nris, by the way, the Natural Resources Information System is an old data set that's been around for a while, built off the completion reports from the Corporation Commission. And there was a time where we had quite a bit of data from the Osage. So we do have some, but anything going forward, we're looking to supplement that with data that we receive from the Osage, our friends up there. So there will be accommodations for that for sure. Yeah, there you can see some things up there now as you're zooming in. So so that is a question, and if I may, I just randomly looking at some of the questions that popped up, you touched on the production data, the age of that data, of those data that's basically whatever they have at the Tax Commission at the moment. That will be what we will use when we get to that phase of the project. There was a question I saw, I think, Mr. Clymer, I think you asked about using LAS files, and I believe if I remember right, certainly when we get access to LAS, we certainly want to incorporate that into this as a delivery mechanism. Any and all data we can get our hands on, we'd like to incorporate into this system, and I feel like we can do that with Mike Kennedy's team, and their help. We'll be able to accommodate those things.
and just another note on the LAS, as the rules change in the Corporation Commission that are going to be conducive to that type of digital format, we're a strong supporter of that. And I think Dave has actually assisted them in bringing some language up to submit to their rules committee. But that's certainly something that we would like to get access to.
Yeah, we've certainly let them know that we're very interested in seeing that be made available. And if it is, that we would love to incorporate it into this. Are there any other questions that we've not touched on? Tani, are you aware of it? Do you have any other questions, Tani, that you've seen come across?
Let's see. Can we print some of the maps?
Yeah, there is a print functionality that we're going to build into this. You can certainly print, and we hope to have some what I call canned printing functionality built into this. So for example, let's say you wanted to do what I call a 9-section plat. Let's say you want to do a 3-mile by 3-mile area around your favorite well. We envision you hit a button, you want a 9-section plat, and it says, all right, where? And you type in the center township, range, and section of your section of choice, and automatically it will build out a 9-section area centered on your favorite section, and have the ability to, there's an example in the slide set that Richie's showing you. So imagine the map on the bottom of the screen there. A user simply was asked in a dialogue, what section do you want? You type that in, and the map automatically builds for you, including whatever labels we decide are relevant, and also a title block where you can put the name of your name or the company's name or whatever it is you wish to have there automatically, and you simply hit print. That would be a nice thing to do if, let's say, you have to go to the Corporation Commission for some reason and you need to bring a map with you. You may not have that mapping technology at your home or office, and this would give you that ability just to hit print and send it to the printer.
Awesome. How far back does your production data go? You might have mentioned this. I might have missed it.
Yeah, again, the production data that we're not serving that up yet. That will come in subsequent phases of this effort, but it will be based upon, right now, it'll be based upon whatever the Oklahoma Tax Commission has in-house. So in their databases. So it's limited to that at the moment, but we would love to talk with different entities about getting other data that go farther back. Perhaps we would love to do that. I just don't have off the top of my head what the limit is at the moment. Perhaps someone else on the call does.
Let's see, it says, why are the OCC wells different spots than the NRIS database?
Yeah, and Richie was kind of showing that earlier. There's some discrepancies. What it is, it's basically the ability to position a well based on latitude, longitude versus footage calls. A lot of the Nris data utilized some coding developed years ago at OU that would spot a well based on so you have a completion report, and in the location section of that report, they didn't take lat longs, they didn't have GPS, and they didn't go out and provide a lat long on the older forms, but they would provide footage calls within sections, in quarter sections, so many feet from the south line, so many from the west line, so many feet. So coding was developed to, connect the dots basically and position and come up with a lat long, derive a latitude, longitude, and then spot the well. That was all based upon a certain land grid at the time. And a land grid is nothing more than a digital file that contains the latitude, longitudes of the corners of sections, let's say. And there's a latitude is, we won't get into the weeds on by the way, I'm a geologist turned GIS guy, and so I don't want to get into the weeds on geodesy here right now, but a latitude and longitude, you can come up with several based on how accurate the map is you're using to determine where you are on the planet. So there are differences in the latitude and longitudes of some of the Nris data versus perhaps some of the more modern calculations made at the Corporation Commission, and therefore they're both the same spot on the ground, but on a map using the lat longs derived, they'll show in different spots. Part of our mission here will be to try to reconcile some of those things and bring them together, maybe even using ground truthing by changing the base maps, out that we have that capability, so you can actually see the well pad on some of the newer wells. And I know the older ones would be more problematic. But there will be differences. That's part of the quality control effort Richie mentioned earlier that we'll be undertaking as a part of this going forward. It won't happen overnight. We have over 500,000-600,000 well spots in the database. It's just not going to happen that quick. So right now we provide both.
What projection is being used?
Yeah. Well, in the first case, in the Nris data set, those were based on North American datum 27. Because at the time we had a land grid that was NAD 27 donated to the university for this effort. It was donated by Phillips Petroleum Company. Certainly all the lat longs you see recorded in the Corporation Commission data could vary depending on when the latitude and longitude was derived. It just depends on the base that you have. But what we're going to strive to do is provide these data in the new modern, there's some web-based, there's NAD 27, NAD 83, WGS 84. Again, I'm getting into technical details. There's even more modern projections that, like Google, for example, uses to produce things on the web. We will strive to get all of our maps and data in those formats so that when you download them, they will line up nicely with your other data sets.
But ultimately, the added strength of combining these two data sets is going to be, because there's a lot of materials that you can see just from kind of toggling on and off. There's a lot of wells that are in the Nris data set that are not in the Oklahoma Corporation Commission data set, and vice versa. So that's the impetus for us developing this kind of master composite listing. But it won't be without its QC pitfalls.
I will say this, though, for all the users using this system, money back guaranteed. If it's not, it is free.
Free.
But, no, we want it to be right, and we certainly have a lot of work ahead of us. One, to build the system, and then to get the data is the hardest part in every data system, in every GIS system. It's always the data. A lot of cleanup to be done.
Awesome. Well, if we have any more questions, please feel free to shoot us an email and I can pass it on, or however you guys want to do that. Thank you guys again for joining us today. Thank you, OGS, for putting this on and putting a lot of hard work into, helping Oklahoma and small producers, and free is always good. So I just want to thank everyone for coming out.
Well, thank you very much for having us. And again, we'd like to, especially thank SOAR, among our sponsors. We couldn't do this project without SOAR, so we really appreciate that, the ability to kind of help us get into
and the Secretary of Energy and Environment. They've been very supportive.
They throw up more.
Ken Wagner and his team have been very supportive of us, so we're very grateful for all of that.
All right. Thank you guys for all coming out. I'm going to end the meeting. Have a great day.
Thank you very much.
Thank you.